Hi, welcome back. Hearty welcome to you. So, in this video session, we will go through half angle formulae. We know in the last videos we have found what is sine A, and also we have found what is cos A. Let's try to recollect that. We have found sine A is nothing but equal to A by 2R, or we also found cos A equal to B square plus C square minus A square by 2bc. How we got this? We know that law of cosines A square equal to B square plus C square minus 2bc cos A. If you take A square to the opposite side and bring 2bc cos A, then you divide by 2bc, you will have this. If I am confusing you enough, let me just write it down here. A square equal to B square plus C square minus 2bc cos A. Now if you bring 2bc cos A here and take A square that side, what happens? This becomes 2bc cos A equal to B square plus C square minus A square, or that gives you cos A equal to B square plus C square minus A square by 2bc. Okay. Now to find out sine A by 2 and cos A by 2, this may not be particularly useful, but we can use this because we know that sine A by 2 is equal to square root of 1 minus cos A, and cos of A by 2 equal to square root of 1 plus cos A. You have 2 sine square A by 2 equal to 1 minus cos A. So 1 minus cos A by 2 by 2 in root. This is whole root because cos square A by 2 equal to 1 plus cos A. 1 plus cos A equal to 2. Similarly here this whole root. Okay. Now let's apply that straightforward and see there is nothing else. We'll just apply the formula of cos A here and we can find out what is sine A by 2. Only the thing remember is we'll be using one interesting which we know that always A plus B plus C is equal to perimeter is nothing but 2 times of S, which is nothing but semi-perimeter, or S equal to A plus B plus C by 2. That is what we will use. Okay, let's go ahead with sine A by 2 here and cos A by 2 here. We'll start with sine A by 2. Sine A by 2 equal to square root of 1 by 2. I will keep it aside. Then I will write here 1 minus cos A, 1 minus of, what is this? I have to write B square plus C square minus A square by 2bc. Right? This is nothing but equal to square root of, can I take 2 also out? So it becomes 1 by 4 into, I'll have BC here, and I will have 2bc minus B square minus C square plus A square. Now I can write it as square root of 1 by 4 into, you can see here this is nothing but A square minus of B minus C whole square. Just to see whether you can understand that or not. If you take minus common here, what happens? This is nothing but minus of B square plus C square minus 2bc plus A square. Is this the same step? Right? And this is nothing but minus of B minus C whole square plus A square. That's nothing but A square minus of B minus C whole square. So I can write it like that. Because you see here B square is positive, C square is positive, and this is negative, nothing but B minus C whole square if I take minus outside. Okay? Right. So I'll just erase this part. Okay, let's come back. Now what is this? This is nothing but equal to square root of 1 by 4 into, I have BC here, then I will have A plus B minus C, A plus B minus C into A minus B plus C, A minus B plus C. That's nothing but equal to 1 by 4 into 1 by BC into, let us see what I have here. I have A plus B minus 2C. Can I write A plus B is nothing but equal to 2S minus C? I can write it as A plus B is equal to 2S minus C. Similarly, A plus C equal to 2S minus B. I can write that. So if I write it, what happens now? A plus B is 2S minus C. That means I will have 2S minus 2C. Here I will have 2S minus 2B. That's nothing but equal to square root of 1 by 4 1 by BC into, I can take 4 common because I can take 2 here common, 2 here common. It will be S minus B into S minus C, or I can cancel 4 and 4. That's nothing but equal to square root of S minus B into S minus C by BC. This is nothing but equal to sine A by 2. Now let's find out what is cos A by 2. You can do it in two ways. You know sine A by 2, you can find out cos A by 2 by using sine square A by 2 plus cos square A by 2 equal to 1. Otherwise, you can leverage the same thing. Let's leverage the same thing. Cos A by 2 equal to square root of 1 plus cos A by 2. So I'll change the color here for this. This is what we are going to do now for cos A by 2. This is square root of, can I take 1 by 2 common? 1 by 2 out, I will have 1 plus cos A. Cos A is B square plus C square minus A square by 2BC. In the similar lines, you can see that this is 1 by 2 BC, 1 by 2 BC into, I have here B square plus C square plus 2BC minus A square. Now can you think how you can write this? How we can write this? I'll have 1 by 2BC into, this is nothing but B plus C whole square minus A square. You can see that this is B plus C whole square minus A square. So this is B plus C whole square minus A square. That's nothing but equal to, I can take 1 by 2 BC. I'll have A square minus B square, that is A plus B into A minus B. So it becomes B plus C plus A into B plus C minus A. Okay. Now what is the formula I am going to use now is, I will say that B plus C is equal to 2S minus A, because 2S is A plus B plus C. Now what happens? This becomes 1 by, I will have 1 by 2BC into, let us check that, 1 by 2, okay, I have 1 by 2, I have another 2, this should become 4. That's what I'm thinking, because if you remember, earlier we got all 4. So that's a silly mistake on my part. This is 4BC. Should I erase that? I will write it again. So this is 4BC. This is also 4BC. Okay. 4BC. Okay, right. Now, what is A plus B plus C? 2S. And what is b plus c minus a? 2s minus a. That means it will become 2s minus 2a. Now this is nothing but equal to, we'll have couple of steps and we are done. This is nothing but equal to square root of 1 by 4bc into 4 into s minus a. You can cancel 4 and 4. You will have s into s minus a by bc. That is nothing but equal to cos of a by 2. You know sine of a by 2, you know cos of a by 2. Can you tell me what is tan of a by 2? Tan of a by 2 is just simply division, right? So it's nothing but square root of s minus b into s minus c by s into s minus a. Similarly, you can find out sin b by 2, sin c by 2, cos b by 2, cos c by 2. All of them. Okay? Right. Now these are called off angle formulae. Now you can leverage this. Can you find out what is sin a? After you know sin a by 2, cos a by 2, you know sin a by 2, you know cos a by 2, just find out what is sin a. Okay? And see what is the value of that. Okay? See you in the next video where we will go through area of a triangle. Okay? Area of triangle. This is about half angle formula. What we have done is very simple. From law of cosines, we know what is cos A. We know from trigonometry there is identity which tells me sin A by 2 equal to square root of 1 minus cos A by 2 and cos A by 2 equal to square root of 1 plus cos A by 2. I will substitute the value of cos A in them and simplify them and leverage this particular condition that A plus B plus C equal to 2s. We are ending up with sin A by 2 equal to sin a by 2 is equal to, see here, if you want a by 2, you will not have a in this. This is s minus b into s minus c by bc. But if you want cos a by 2, you will have s and a, s into s minus a by bc. If you want a, you will have bc. So they follow a pattern. Now can you tell me what is sin b by 2? Sin b by 2 is s minus c into s minus a by ca. Similarly, cos b by 2 equal to s into s minus b by ca. Similarly, you can find out for all of them. See you in the next video where we will go through area of a triangle using trigonometry, something like half ab into sin c, half bc sin a, and also we will find out how we got the Heron's formula that area equal to square root of s into s minus a into s minus b into s minus c. See you in the next video. We will discuss that. It's going to be very interesting. Thanks for staying. Bye for now.